Here, I'm Ted Turner. I'm the cloud architect for Kentik. I've been here with Kentik for 2 years, and I've seen some pretty neat stuff that we're able to get done. Kentik focuses on network observability. So if you think of the network being underneath that infrastructure, all the things underneath, a lot of your telemetry systems, a lot of your observability is focused on the application and code. So your developers, your JavaScript, your C, any of your Java programming language, Rust, stuff like that, they've focused on that level of observability, and so you can infer what's going on, but a lot of organizations have skipped the rest. You can get a little bit of CPU and memory from your servers, stuff like that. We wanted to tie together the rest and understand what's going on in the cloud, going into your infrastructure, your SD-WAN, and your backbone, your internet. So we want to answer questions. When will it be at capacity? What does distribution across all of the regions in the cloud look like? What's driving latency in this direction or that direction? Those are the types of things we're trying to figure out and answer those questions. So network observability. Nobody seems to be picking up that. Observability seems to be a thing. Some organizations are picking up network observability, but it's that lower half of the observability spectrum. So ask a question about your network. Well, when something has gone wrong, everyone blames the network. What's the first thing everybody blames? Well, DNS. What does that mean? So we want to provide that visibility, helping understand what a DNS query, what that latency looks like for that DNS query. So if you've got multiple DNS servers, you're able to query and pull from multiple of those DNS servers. If you're using the cloud, any of the 8.8s, 9.9s, any of those, we're already pulling against those, gathering that information for our customers, making it available for free. And then you can test against your particular infrastructure and help tie all those things together. So telemetry, graphs, charts, tables, but we want to go beyond that. We want to get deeper. We want to increase that, the enrichment, get that geolocation. We're grabbing routing tables, BGP routing tables. We're grabbing the network routing tables in your cloud providers now. So that's something new. I'm going to show that off when we get into the show and tell portion, and you guys can ask more questions. We're actually gathering that routing information from the cloud providers and help us understand how that's going back into your particular infrastructure. We're pulling in those security groups, DNS information, the BGP. We're grabbing passive and proactive. So not only what your cloud provider is telling you, not only what SNMP and flow logs are telling you, but we're actually actively testing. We have some synthetic agents. So we have synthetic agents that we've deployed globally around the world that you can incorporate and test against your infrastructure across the public internet, as well as that agent that we've open sourced. You can put it on your network privately and test across some of your private pathways. So we're trying to do all of the things together. So you still have problems. Everyone just says it's slow. It doesn't work. So how do you start to focus in? This is what we're trying to get to, adding those VPC flows, the host to SNMP. Get beyond that legacy visibility. Hey, I can see all the things. You can answer the question, why is the app slow? That's still a hard question to answer today. So traditional visibility is going to tell you what's happening. Observability is going to help you understand why it's happening, taking that passive and active approach. So we want useful intelligence. We want to infer what's going on. We want to automate what's going on with a high degree of accuracy. So we have to pull information from a number of different places. So how do we do it? We're ingesting huge amounts of data from all over the place, your physical infrastructure, your routers, your firewalls, your switches, anything that generates flow. We're also grabbing the same similar information from your VPC flow logs in AWS, your NSG flow logs in Azure, and you're able to pull all of this back in and understand it, record it at scale. We're able to classify. So as those flow logs are coming in, we're going to decorate that with the additional information. So we understand what that ENI is from, say, a VPC flow log, but we don't necessarily understand what the DNS is. We go gather that additional information about the DNS and record that in the database. So we're going to dump all of that into the database. Once we start seeing all of that information show up in the database, we run a third set of data in the database so that as you're working in that data, We can do some of that AI and analytics on the back end. And so we can do the anomaly detection. We can start to see what some of those things that shouldn't be occurring are occurring and help bubble that up, gain those insights, maybe fire off an alert, maybe integrate with ServiceNow or PagerDuty and help you become aware that something is anomalous.
Are you using local collectors in order to maintain local pools of data? Because as it's streaming in, if there's a connectivity issue and ultimately it can't get back to the mothership, I presume that there's like sort of a SaaS backend that's hosting all of this goodness. But quite often the problem is if the network's failing, well, the same network's the one that's actually streaming your data to the mothership. So do you maintain at least local data and then ship when available?
We don't maintain local data. We have about a minute's worth of local data in that local. We have a kproxy, a small appliance deployed that has a finite amount of memory on it. And that's replacing any of the physical appliance that you would typically deploy previously.
Right.
So we just did a deployment, 3 data center, 3-tier deployment. All of the devices are shooting that data to a kproxy cluster. So it's a clustered deployment. And then should that IP address disappear, that data center goes offline. They actually pulled the plug, made that IP go away. It shifts over to another kproxy cluster in another data center. So all of the resources physically that we're talking about here at this time will just redirect to another endpoint and continue sending flows. We're able to successfully get through that same scenario.
Right.
In the cloud, we have an ingest pipeline. We collect data near each cloud provider. So we're running in the cloud right next to our customers. We're able to leverage that.
Is it like a VPC peer to the customer VPC, or I say VPC, whatever the customer tenant network, or is it simply just that you're close enough?
We're close enough so that we can use a security model, number one. And then as we pull the data from the cloud to the cloud, we're reducing the cost for our customers. So those are the 2 pieces that we're trying to do. We roll up the data and then we shoot it back out to Kentik. And so we've got multiple paths to get that data from each cloud provider back into our backend. On our backend, we have 2 different physical data centers built at co-locations with PNIs, multiple pathways coming in. So we're redundant in virtually every aspect from the customer consumption model side, getting the data to Kentik, as well as being able to service that data for all of our customers in a intelligent fashion, reliable fashion.
Great.
So if you're egressing that much flow information and telemetry data, does the bandwidth consumption for that scale with the lengths that it's on and its overall utilization, or is it a static bandwidth rate that you're consuming for all that information going out?
So at large, as that bandwidth increases, you're going to generate more flow logs.
Right.
So that's going to increase. So we have the kproxies that we install. A number of our customers have to have an array, a cluster of proxies to be able to handle all of that traffic coming from their on-prem devices. In the cloud, slightly different answer, basically the same answer. We run Kubernetes clusters per customer. So as they have an ebb and flow to their network in the cloud, their VPC flow logs, their NSG flow logs, we're running on that cloud platform in a cluster, and then we scale that cluster to the customer's needs. So at large, we have the telemetry pipeline underneath, grabbing data from a number of different sources. We bring it into our platform, and then we're able to solve problems across a number of different pieces of the spectrum of where problems can arise. So network observability is built upon traditional visibility, but traditional visibility hasn't helped you understand why. It just helped you understand that something was happening. We're trying to get to that why aspect. What am I going to need to go fix? Whose hands are going to need to go do that? And so from the backbone provider, do I need to call my service provider, my ISP, the backbone, my cloud provider? Or if it's something I can touch, who do I need to call to make my stuff work? So this is where we get into demo mode. This is Kentik. This is our Kentik map, where we are showing the top left corner is Amazon, and we're showing off the bandwidth consumed. So that question that we had, as that traffic ebbs and flows, we can see what that looks like here coming from Amazon going to the on-prem locations. And this is showing the world map here. So that weather map type view of what's going on.
Are you gathering any distinct metrics that are behind the customer environment in AWS native networks, or are you only getting customer visible network data from their own VPC? Like, does AWS show you data that we don't see?
AWS provides a ton of data. At large, you can see it all. It's just in a number of different locations. And I think you're going to like what I'm going to flip to next, because we take a lot of that additional information, that telemetry about what's going on, and we start to display it on screen. So at large, we can see what's going on the backbone of the internet, all these different AS numbers. I'm going to go here to Amazon real quick. We're going to go into Azure next. So if there's AWS or Azure questions anybody has out there, if I knew the Google guys were going to be here, I probably would have made sure I brought the Google guys in, but that's not going to be part of the presentation today. So what we're looking at here is we have the on-prem here on top, and we're showing that path of where that traffic is going to and from. So if I scroll down, click, I can see that it's coming from US West 1 here through this particular transit gateway. I'm going to go back up to the top. So I'm here on this card router here. These are the details about that we're getting through SNMP. These can be flows arriving from that physical on-prem device, and we're correlating that information through that pathway, going in this case through a VPN. So when I click on VPN, I'm changing my view, I'm changing my perspective. And you'll notice one of the things, there was a graph there that disappeared. So the graph that disappeared was helping me understand what was going on on-prem, what those flows, what that volumetric rate of those flows going through that device looked like. When I clicked on the VPN, it's terminated on the other side. We don't have that much information. So not everything. One of the things here I'm going to highlight now, as we hover over any of these graphs, it's hard to see there, but it says View in Data Explorer. That View in Data Explorer is your view getting into the backend database. That super fast, big MAMU of a database. That's how you get in and see some of that.
So you have a big gnarly graph database that's probably making the folks at Influx nervous by how much you're stretching their capabilities, or whatever the platforms are that you're in.
Yes.
Any proprietary stuff, or are you based on some of the open systems out there today?
We took the open systems and then extended them. So it is proprietary. It is basically a graph database. Do they have needs to be worried? We do the ingest at scale, that fast ingest, decorating the data as it's coming through. Most of them, it's hard to say that we're competing because it's so big at that infrastructure level. People just don't build that. You have to deploy so many appliances. And so we take that and we send it back to Influx. We take that and we send it back to Splunk. So we don't want to be that big bad competitor taking everything off the table. We want to work with everybody. But what I'm getting into here is these are all the types of things that we're grabbing that become hard. And we're putting it into our database in a way that we can reference it and help understand, say, the transit gateway routing tables. Which networks are going through which? And so all of this is at large underneath based on flows, source IP, dest IP. Once we see that, we say, hey, tell me more about it. In the AWS world, we use the describe API that says, tell me more about that VPC. Tell me more about that network. Tell me more about the routes. Oh, the routes tell me, oh, I've got a transit gateway. Well, please tell me more about the transit gateway. So that all future records coming in, we're gathering about a 10 to 15 minute time scale. So we're able to see those changes when that routing changed, when the security groups changed, et cetera.
So how much data is polling versus how much is capturing on streaming? Sorry, I should give full disclosure. I worked for Turbonomic and we bought Sev1, so I know a little bit more than your normal person would care to know about this kind of stuff. So I'm gonna ask a lot of gnarly questions.
So to answer the question, the big portion of this is flows are the big.
Right.
The extra telemetry is almost a rounding error. SNMP for us is almost a rounding error on that back end ingestion. But having that SNMP, having those records from the AWS Describe API, if you're in the Azure world, using that graph.microsoft.com to be able to describe that environment, that allows us to pull that information in on a periodic basis and keep things up to date. Because in the cloud, things change more often than say in your on-prem world.
And how often do you maintain that level, that state, along with the time series database based on flow? Like, do you have basically like have a point where you go back and say, 19 minutes ago, this thing occurred, and this was the general state of this EC2 instance, and then yesterday afternoon we noticed it suddenly got shut down and respawned onto a different host or whatnot. Like, and you can begin to correlate because you've got a lot of really high cardinality data that you're going to pull together, and you combine that with the Describe API alone, which is, I don't know, like 47 elements or whatever it is. It's a lot of data.
It is
It's a combinatorial mathematic problem. It's fantastic. Congratulations on solving it.
I work with great people. I work with great founders. To the meat of your question, we cap at 45 days. We have what we call diagnostic data, and then we start to roll up.
Right.
And then any customer can pay us, and we will extend that length. So some customers have a periodic scale of, say, the end of the year, festivities, stuff like that, back to school activities. They might want to see a year's worth of data. We have the ability to extend that in the database. It's not hard for us because not many people reach back in time and go into the database like that.
Is that going to be like sub-second or second, or like what's the sort of range that which you maintain granularity for that data store?
So the granularity for the data store is generally in 1 minute buckets. We're going to bucketize everything in 1 minute. When we get into the synthetic testing, when we went to the backbone providers, they said 1 minute is nowhere near sufficient. We want 1 second tests. We want that 1 second granularity. So with the synthetics, that proactive testing, we're able to do that 1 second granularity. Almost all other data, all of the other flows are going to be that 1 minute. And then with that polling interval to get that additional data to decorate that metadata, that's going to be on about a 15-minute polling interval.
And is it, sorry, I'm asking a lot of stupid, silly questions. Is it rounded across that minute? Do you have like, mean, average? When you take that interval, a lot can happen in a minute. And depending on what choice you choose and how you render that.
We actually love these questions. We do all of it. So we calculate all of it so that we're understanding what the max interval was. And so that's not getting topped off statistically. Because as you start rounding those over time, it makes things harder to see.
Yeah.
The roll up data after certain amounts of time?
After 45 days by default, and then we keep it, keep me honest here, guys, 120 days for the rolled up data.
Right.
So that's what we do out of the box on the general license agreement.
And then so after 45 days, it becomes more than a minute.
After 45 days, it becomes more limited.
And how much is that value?
I'm sorry.
How much is that value? Like you store a minute of granularity for?
It's 1 minute granularity for 45 days.
Yeah. And then afterwards?
And then afterwards, we're going to start doing 5-minute rollups
Right.
for that 45 day to 120 day window. So as we come down here, we hit that US West. We go jump in, show details. So now we're looking at a subnet. We see the CIDR block for the IP addresses. We see which account this is attached to. So one of the things that we find in the cloud is the service providers need to protect themselves. They need to protect their other customers, and they need to protect a customer from themselves. So they rate limit. And so as you're trying to get stuff done in the cloud, oftentimes you're rolling through and you run into some sort of limitation. And so you're trying to get application cache register running up alongside of application identity management. And all of a sudden, those two are butting heads, consuming resources, and the cloud provider's not letting you grow to the scale you want. So what's the answer to do to fix that? Spin up another account. With another account, you get a whole new set of quotas, a whole new set of rate limiting APIs. And so a number of organizations end up with account after account after account. Where I came from, I did a 10-year stint. When I left, we had 2,000 production accounts, 2,000 pre-prod accounts where we could go test and evaluate anything, and then a whole handful of dev test, trying to figure stuff out accounts. So 4,000 going towards 5,000 accounts. threading all of these pieces together for a network engineer or a cloud engineer, anybody else trying to figure out what's going on, it's hard. And so we start to annotate what that account ID is. So for this VPC in this region, we understand what that traffic is based on flows, that information, what those names are in, say, Route 53 or DNS, how all of these things relate to each other, plus whatever that management backend is. VPC ID, here we've got that data explorer. For that particular availability zone, we understand what that route table is specifically for that availability zone, how that's going to relate up through that region, and we can actually follow who can talk to who based on the routes. And then a little bit further down, we've got the security groups. So this is actually denied traffic. In your flow logs in the cloud, Microsoft and AWS will show you, hey, you had this attempt at communication and it got dropped, denied, it is not permitted. We record those, we show those, and then you can click on these and view the security groups and now start to relate who was trying to talk to who. You saw the drop traffic, so you know it's not getting through. And now you can point someone to a security group that's actually blocking the traffic. We just had a customer go through the process of shutting down a data center, migrating fully into the cloud. They went and turned off the firewalls or decommissioning the data center. They're still getting billed for the data center until you tear it down. So if they're in a rush, let's go, let's get rid of this data center, let's cut our costs. Wait a minute. It's broken. The cloud's not working. You're like, wait a minute, everything's migrated to the cloud. What do you mean? We're decommissioning the data center. They say, can you turn it back on? They found 400 servers that somehow got missed in the whole program management cycle. And so they needed to migrate those 400 servers out into the cloud. Since they've been doing this, they understood what this looked like. They understood the process. And every time that they got a new server, a new application running out in the cloud, it wouldn't work. Well, with this view, within 2 weeks, so they've been shutting down their data center for months, had 400 servers left over at one point. They're able to migrate those last 400 servers in a 2-week interval because we could show them exactly what's going on in the cloud in the account that they needed to know about.
So this is surfacing information in, I think, a really awesome way. The question I have is, does Chemtech do anything in terms of machine learning, figuring out what's actually wrong and surfacing that up to you without you going to look for it?
So we have, and I'm not prepared in this demonstration today to go into the alerting section. And so we have the database, the ingest, the diagnostic level detail. Then we have the analysis section, and then we have kind of the AI, and a lot of this alerting comes from that third copy.
Yeah.
So as the information is flowing into our pipeline, our ingest pipeline, we decorate it, and then we send it to 3 different unique databases.
Mhm.
And then this section here, that alerting, gathering those insights, we try and avoid the word AI. We used it one time in marketing, and everybody went wild. Oh, we're going to do security. We're going to do, wait a minute. We have a bunch of really smart people, but that's deep analysis in a lot of different areas.
Yeah, it's
We have,
anomaly detection, basically. Yeah.
we have made that available, but we haven't gone deep like I believe you're asking.
Right. Okay.
Or at least you can see like pattern, like your DDoS, and there's patterns that occur that begin to look like a thing that's occurring, and then you can
The DDoS
aggregate that into some kind of a thing.
Almost like predictive analysis.
got it.
Are you home rolling your rule set, or are you using some of the open rule sets that are out there?
We are currently rolling our own rule sets. We got pretty darn good at that DDoS detection with the backbones. So that's a lot of what we're leveraging our knowledge and our talent and building the scalability of it. We are interested in these conversations that we're having with the wider community. We have the open source component, so we would love to go in and do a lot more. There is always who owns the data.
Yeah.
So if you have data you can send to us and we can work out some of the analytics, we would love to have those conversations. but oftentimes it's a backbone provider, et cetera. They don't necessarily want to let that out. But if you know any of those backbone providers, any of those teams, we're deeply entrenched in the networking teams. We're here today to make the cloud teams aware. These are the things that we do, and we have these capabilities, but we haven't gone as deep on some of those capabilities. We'd love that opportunity. So quick show and tell. This is Azure. So the Microsoft Azure portion of the world. We're doing a lot of the same things. As we're moving into the third quarter, we have started to get into the virtual WAN. So a number of the network constructs that Microsoft is providing. They're providing kind of their own SD-WAN using their backbone to get your traffic routed around the world. So it's a Microsoft virtual WAN. We are adding that data, that metadata, those routing tables, so we understand what those VNets are, how to get them through. Microsoft has also moved from network security groups, which is more of a point-based security structure for each network VNet. And they're moving it towards Microsoft Firewall, which is more of a global firewall, and then you apply that to your other structures. NSG Flow Logs is where the product started. This quarter, we're moving into the firewall diagnostic logs, which is a separate set of logs. We are now incorporating those, and this is how we're trying to add more detail, more capability, not only in the cloud, but from cloud provider to cloud provider, as well as taking it back to your campus and your data center. So I had told you I was going to show off just a touch and show you the back end Australia.
As far as the user experience in the UI, definitely we still have the very strong network-centric and network-focused view, which makes sense. But thinking of the cloud consumer, where they'll probably want to see like workload, they're going to look for virtual networks, VPCs. They have almost a physical representation of their logical world that acts differently than us network-loving folks tend to render.
Yes, so I came from that network rendering and had to work with a number of different application teams to get there. The first pass was moving from San Diego up to Washington State. And that became a latency problem.
Mm-hmm.
So an authentication that would normally be completed in about 11 milliseconds was now taking 1.2 seconds. And that broke the product where I came from. So there's some structures like that we can start to surface here, and then getting that application view. So some of our customers are using the SaaS services from the cloud providers themselves. Some of them are using WebEx or Zoom, and they're using it from their campus, or their cloud to the outside world, and they need to see what that looks like. And so it's more of an application perspective, using S3 buckets, stuff like that. And some of our customers are building stuff themselves. They're running their own Kubernetes clusters and running their applications. And so some of this is going to focus on what the applications look like from a standard point of view of a WebEx or a Zoom, just as a placeholder. And some of it's going to be a little bit more narrowly detailed. How did that application team or that development team deploy that stack?
Is anyone using GNMI other than the people that wrote it and the four of you folks in the network observability space that are trying to push the standard? It's all SNMP everywhere, right?
It's a lot of SNMP.
That's all good. It's all good. Just checking.
So for our data sources, we have all of the data sources streamed off to the left. We don't actually drop anything. We record everything from wherever its source is. So a lot of tool suites, if you see the same data again and again and again, that cardinality becomes a problem. Well, we maintain where it all originated from, every VPC that it came from. So as it's originating from all these different places, we keep it all. And then we annotate where it came from, which particular interface, which particular VPC. So we've never dropped any of this. So it helps. I love your eyeballs over there.
I'm just thinking of the level of cardinality in your data.
Yeah.
Yes.
That's got to be mind-boggling.
But that's not how we built. We have a graph, so we build the relationships.
Yeah, okay. Yeah.
So I'm just going to keep this focused on AWS right now. And then we have dimensions. These are the dimensions that we make available that you can then query and hit our backend database and start to craft your views. We can then turn that into anything that can be shared with your team members. You can build some dashboards, put different context in there, build it in a table format, in a Sankey diagram, pie diagram, a lot of different ways of portraying the information. So a lot.
Yes, it's like just like a Grafana type of flexible front, and do you expose the query language itself? There's like a raw graph query.
Not a raw graph query. We have an API and we have a description of how to use that API to pull back graph, table, the results you're looking for.
Yeah, because of course your nodes will have different names than some people will understand because there may be some proprietary Kentic goodness inside there.
We'll call it magic.
There you go.
So at large, starting with the IPs, that's the basis of all of this. A lot of the rest of the information around this is the metadata that we're collecting. So that when we're down here into the Amazon Web Services, the account actually shows up in the flow log, the ENI, but the image ID and instance type do not. We're using that Amazon Described API to go get that additional metadata so that the network engineer can have a better conversation working with the rest of the world. Really, ultimately, that's what we're trying to do, is take this underlying information and build better conversations about those application views, that cloud consumption model on top.
How deep do you go into the services like EKS, ECS? Like how far in can we go, or do we have to sort of cheat and come from the top and use eBPF to pull mesh data and such from a Kubernetes cluster?
That was a long.
I'll take you down a deep road with Kubernetes. I'm just. What other services do you tap information from today in the cloud landscape? I only mentioned AWS because it was up there on the screen.
So here's some of the Kubernetes we expose. So the pod namespace, the standard pieces of that.
You pulling labels?
Not here. We do pull labels out of the cloud in other areas, but not
in
this Kubernetes portion. In the come on.
Roadmap? Kubernetes, we kind of depend on labeling / tagging. I still get mad that we call it labeling instead of tagging, but
yeah.
In their defense, Kubernetes labeling is a different animal than cloud labeling.
100%. Oh yeah.
Well,
Just especially thinking of like when you look at life cycle of flows into a point where you have ephemeral containers and networks that are persistent networks leading to ephemeral networks and ephemeral containers, labeling will be critically important because those OIDs change, like a lot of stuff changes. And then to go back over time, if you don't have the labels, it's hard to see exactly what was going on in the app layer.
The Kubernetes section of this is beta.
All good.
Because we recognize that.
Yeah.
And we come from the networking world. At large, it's flows and IPs underneath, but there's a relationship with everything on top. There's a relationship with your Kubernetes on the cloud, whether you built your own cloud infrastructure yourself on VMware or you're running on a cloud provider, going across the internet backbone, it's just IPs. We can relate all of these things together. We have a story to tell.
eBPF will get you there at least, so you're on the right path. So, all right, I'll stop asking Kubernetes questions now.
Yeah,
And so,
but as an extension of that question, so as we talk about more traditional like cloud workloads, is there support for like using tagging as like a way to group things like that?
is there a way to support the tagging? Yes. So if I edit the dimensions, we scroll here, we have instance tags.
Excellent. Cool.
So that was one of the first things that I impressed upon the team when I came on. We were mainly a networking focused company who had just started importing flow logs from the cloud stuff. I said tags, we tag everything. We don't want to track anything. IPs are ephemeral.
What sort of dimensions do you have for like vSphere or VMware?
vSphere and VMware. If you do a quick search in our KB article for VMware or vSphere, makes me sad. IPFix, NetFlow, we can ingest that, we can incorporate it, but that is, as we've moved into the enterprise space, that has not been something that the customers have indicated that they wanted, that they're willing to spend money on.
Really?
Tanzu seems to be there already. And so we haven't made that investment in the time to be able to collect that. We were at the VMware Explore a couple of weeks ago. We had some great conversations. People seem to be pretty excited, especially seeing the cloud components in addition to what VMware can add on top with that vSphere capability. So we're working our way through what those opportunities are right now. I'd love to talk to you more about that because I have a lot of ideas. I came from that world and I'm like, we should do this.
To put it a little different spin to that, we do have a hyper-tagging API, right? So a flow comes in and you want to associate some sort of data with that IP address, right? And it's always changing. So we have an API that allows you to add another column to the database. And then what we have is populators. And these populators use matching techniques in order to tag that additional information to that flow. So at the end of it, the tag comes into place. You have an immutable record with that tag associated with that flow. So it's not that we don't necessarily do it, it's that we don't necessarily do it out of the box. So if you have VMware IPFix data coming in and you want to enrich it with your tag data, it might be usernames, it might be whatever IDs you want. It could be stuff that you're pulling out of the VMware API to enrich that with the hyper tagging. You can do that. So you can do that with any of the flows. And that's really kind of what we do with the AWS tagging stuff. We're taking that data that we're pulling from the API and we're enriching that flow data in order to create these really wide records in this columnar database. And like he was right, it's really hard, right? That's a lot of data. It's very high cardinality. It's hard to deal with, and getting good query times out of that volume of data is insane. So I figured I'd just jump in and help you out with that, Ted, because
we don't do it out of the box on the back end with the capabilities like Mike called out. We can do it. We've built our back end to do these things from our start in life as a company, being a networking company. Making that pivot hasn't necessarily made sense, but as we engage with customers or anybody who wants to do these things, we do have that back end ready to go.
But to your point, I was going to say, to your point earlier, are your customers actually really asking for that though? I mean, from the whole VMware perspective.
From the VMware side of the world, no, because we're that big cloud scale. They're already running in the cloud. Backbone providers, they're using other technology than VMware. That's not something that our current customer crop has been asking for.
When you mentioned there's 3 targets where the data lands, is that because you have to solve a performance problem because your queries can be done in one place, your analysis can be done in another? Like,
so at that point, I'm going to defer to Magic.
Yeah.
And
yeah, I mean, they're different data pipelines, right? So there's different aggregations that are being done. So you're doing an analysis. If you're looking for port scans, you only need a certain set of data, right? So that's going in. And so as we're doing analysis, we're looking at certain streaming data sets, right? And then we also have that immutable columnar data store where we're putting all of that data so you can go back and query it. So they're different things. They're doing different things in order to provide different services. So that's kind of what that's like. And to that end, that streaming is what our Firehose product does. So basically, if you turn the data after it's been enriched and send it into your own Kafka bus or whatever, or wherever you want to send it, it's all yours, right? So we have the ability to basically fork that off. And so that's kind of what we're doing when we're sending it different places.